Hey guys, so in this video we are gonna take a look at the cross validation and score, and I'm gonna tell you why cross validation score is so important. So what happens with our normal training is that let's suppose you have this data. This is just don't focus on this part right now. Just take a look at this part. So let's suppose you have this data and this is your whole data, and what you have done is that you have split this data into training data and test data. So what you are doing is you are creating your, let's suppose, decision tree, and you are training your decision tree on this part, and you are testing on this part. But with what is the main problem with this is that sometimes what can happen is that your decision tree or your any other algorithm can be biased to this data. It means it can overfit to this data. So what will happen, you will take some different values. Let's suppose these are some values, and you want to predict on these part. This is your test data. So now it can give you very bad results because it has always trained on this data, and this kind of data is not included in this part. So this shows that the algorithm was biased to this part. So to detect that and to understand that, what we use k-fold cross validation. So in this, what we do is, let's suppose we are doing four k-fold cross validation. So in this we can take k as 4. So we are doing four fold cross validation. So what we are going to do, we are going to split the whole data in this part. Okay, and what it is going to do, it is going to train on this part, then it is going to predict on this part. Let's suppose it is giving some accuracy of 80%. Then what it is going to do, it is going to get this part and this part into the training part, and this will be the testing part. So let's suppose this is giving an accuracy of 90%. Similarly, then we are doing this part and this part for the training, and this for the testing. Let's suppose this is giving us 78% accuracy, and the last we have this part for the training and this part for the testing, and let's suppose it is also giving us 80% accuracy. So now what we are going to do is we are going to take a mean of all of these output, and what we can say, let's suppose our total or our mean accuracy is around, let's say, 83%. So now we have 83% accuracy. So we can say that yes, our algorithm has a good accuracy overall, and it has not been biased to just a single part. Okay, so this is the main concept behind k-fold cross validation, and let me just show you with the code also what or how we can use this. So what you need to do is, from sklearn.model selection import cross val score, and what I'm going to do is accuracy equal to or let's not do that. So I'm gonna use cross val score. In the first as a first parameter, we have to give the algorithm that we want to use. So I'm gonna give the random forest classifier, and in this I'm giving, let's say, n estimators, or that is so let's just give the criteria and max step. So criteria equal to is going to be entropy, and max depth is going to be 5. So max depth is going to be 5. Now what we have to do is we have to give the training data, or we have to give the whole data basically, not just the training data. So df features and df outputs. Okay, and what I'm doing here is I'm giving the cross validation fold as 5. So it is going to divide our data 5 times, and it is going to perform the same thing 5 times here. Okay, and what I'm going to do, let's first just run this. So as you can see here, in the first part our accuracy was 75%. so when we had this data, whole data, and let's suppose this was the testing part and this was the what do we say, training part, our accuracy was 75%. Okay, now let me just start this. So now what has happened is that now this part is the testing part and rest of it is training part, and in that part it has given us 83%. Again this steps is going to move forward, then it is going to 79%, then it is going to 80%, then 85%. So if we want the overall accuracy, then we have to take a mean for that. So that is going to be dot mean, and the overall accuracy is 81%. So it means that our total model is our overall model is good. So now is the main reason that you want to use cross validation score is when you are getting, let's suppose you want to you want to make a model for iris flower detection. So for that, what you can do is you can use logistic regression. Okay, you can also use SVC or SPM if you say, and you can also use decision trees as we did here. Okay, so you can use all of them. Now let's suppose what you are doing is that you have this is your data, and you have just split on this part. This is testing, this is training part, and you have performed logistic regression. Okay, and it has given 80%. Now you thought that okay, this is giving you a good result. You did the same thing with SPM, you did the same thing with decision trees. Okay, and this was giving, let's suppose, 75%, and this was giving, let's suppose, 85%. So you thought that okay, decision trees is the best, then the logistic regression, then the SPM. But you will never know, because you do not know what kind of data was here and what kind of data was here. So for this, what we are going to do is we are going to use cross validation score, and what we are going to do is we are going to see, okay, in this part this is performing 80%, then in the second part, if we choose this part as the training part, if we choose this part as the training part now, so what it is now, it is giving a very less accuracy, or let's suppose it is only giving 60% accuracy, but this is giving 85% accuracy, and this is also giving let's say 84% accuracy. So now you will say okay, so overall this result is better. Now let's suppose you have chosen this part as your testing part and every other part as training part, and now you will see that okay, still you are getting 65% accuracy here, but here you are getting 75% accuracy, 76% accuracy, and let's say 90% accuracy. So now your perspective has changed, because first you were thinking that okay, logistic regression decision tree was best, then logistic regression, and then SPM. But now your perspective has changed, because now decision tree is best, then SPM, and then logistic regression. So in those cases you can say that okay, on overall data, my decision tree is working best, or let's suppose it is giving 20% accuracy in the last part. Let's suppose it is giving 20% accuracy. So you can say that no, decision tree is not the best model for this kind of data. We should use SPM, because it is giving good results, 75, 85, 76 on every kind of data. So this is giving good results, so we should choose SPM. So this was the main intuition behind the cross validation score, so that you can get a good idea about how or what model you should use. So this was it, and thank you for watching, and I'll see you next time.